This is lesson 21, day 3, I think we're at. I'm going to recap on the tests for functions, because remember, we have things called relationships, we have things called functions, and we have things called one-to-one functions. To be a one-to-one function, you have to be a function. To be a function, you have to have one output for every input. To be a relationship, it's the other way around. You just have to have an output for an input. Yes? So, going through our categories here, we'll have something that sometimes we'll either given a graph or a set of points, and we're going to have to say, is it a function? And so we use something called the vertical line test. It says that if I graphed the coordinates, a bunch of points, or I'm given a graph which is just a representation of all the coordinates that could possibly be, it says if I can draw any vertical line anywhere on that graph, remember vertical line goes up and down, and it only touches the graph at most one time, then it is a function. If it touches more than once, it's not a function. Our next slide, we're going to see a bunch of these types of things. The second one is that once I've tested it and I said, hey, it's a function because I'm only hitting it once or less, we can go do something called the horizontal line test. The horizontal line test says that a function is one-to-one if a horizontal line does the same thing, only hits the graph once or less. So horizontal, remember vertical is up and down. Horizontal is not like that. More like that. A horizontal line is straight across. And if it only touches the graph once, then it's also a one-to-one function. Exactly one input to exactly one output. Okay? So, what are we going to do? We're going to see a couple different examples of all of that next. So, guys, if I'm given a set of points, it's real easy. I like this. Now, for our domain and range, basically these questions are asking three questions. What's the is it a function, yes or no? State the domain and state the range. Now, when I am given something like this, of a set of points and stuff, interval notation's not as good. So we'll just stick with set notation here. So sometimes it's better to use set notation over interval notation, because if we're talking about ranges, then interval notation's okay. But they're not here, we're talking about individual values, okay? So, we have this set of points. We have to figure out, is this a function? Yes or no? And why wouldn't it be? So this is how I tell if it's a function or not. I look at all the x values that are going in. A 17, a 15/4, a 15, and a 17/4. Do they repeat themselves? Does it repeat an x value going in? In that case, it's all different x values going in. That means they all can go to whatever points they want. This is a function. It's a function because every input goes to a different output. Because I'm not repeating an input. I'm only using 17 once going in. 15/4, 15 and 17/4.
So the x value is always the
inputs, right. In this case, x's are in, y's are out. Now, let's just skip over the range and domain real quick. Go to 4. Are we repeating any inputs there? Yes. We are going to repeat the -3. The question is the output then the same? No. So is this a function? No. Not function. I don't know. I could just put no. Just put no. No. Not function. So, okay. So yes, it's a function, or no, it's not a function. In this case, it's not a function. Now, let's go over what the domain is. Go back to 3 now. Where I said that using set notation is going to be a little easier because here, all I have to do when I have to list things is just list them. Put them with the set notation on it. So what's my first x value? 17. Next one. 15 fourths. Next one. And 17 fourths. Done. That is the domain of this particular set of points. What would the range be? 15 over 4, 17, 17 over 4, and 15. Okay? So when I'm given a set of points, it's not that bad. Very easily, I can find the range and the domain. I'm going to skip writing that down for number 4. Please, you guys fill it out as practice. A range are the y values. Now, in number 5, it's saying that it's already been graphed for us. It says, write each of the following as a relation, state the domain and range, and then determine if it is a function or not. Now, what it basically means as a relation, it wants you to state the x, y points. Okay? So each one of those, it'll take a little bit of time to figure out that. I'll let you guys do that, but remember, we'll just do the first dot down here. What would this dot be? Negative 2, negative 2. Okay? And then you go to the next one, do the next one. That's what it means by state the relation, or the relationship between the points. That would lead us to the domain, like we did above, yes? So do I need to spell part of the domain would be negative 2. Part of the range would also be negative 2. Well, let's pick one more point. Which one more point here? Let's do the one that's above it. What would this point be? Negative 1, 1? So therefore, negative 1 goes in the x and 1 goes in the range. Right? And you just keep going. We did that stuff above. I'm not too worried about that. You guys should know how to list a point. The question is this a function, yes or no?
No.
This time, I'm given a graph. And I'm going to take these circles out of here to get less confused. The question is, can I draw a vertical line, any vertical line, and it only touches one point at most?
No.
Well, let's take a look. Are we okay? Are we okay? Are we okay? No. If the line was straight, this would not be okay because I am hitting 2 points. So therefore, not function. The set of points. Keep listing your set of points. List them all, yes. Again, I think you guys can handle that part and the rating of the domain and range because it's just your x and y values. In number 6, there's only 4 points. So you would list all 4 points. You would set the interval notation, or not interval notation, set notation for your domain and range. Let's just do the first point way up top there. What is that? Negative 2. What is it?
3.
That is 1, 2, 3, 3. That is negative 2, 3. So in the domain, you would have negative 2. In the range, you would have 3. I don't think I was recording when the question asked before. When we state the domain and range, especially on number 5, where there's 2 y values that come out, you only have to state the one y value once. So, or the x value once. So if it's repeated, you only need it once inside your range or your domain. Okay, so then you just put commas and you keep going, right? Now, let's test it with a vertical line test. Function? 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 Yes. Now wait a minute. This is a function, so therefore can I take it to that next step and say, is it a one-to-one function?
Yeah, it is.
How many times? How many times? How many times? How many times? So this is also what we call one-to-one, not comma. One-to-one function as well. Put 1-1. One-to-one function. Okay?
Are those better than regular functions?
Number 19 is a parabola, it looks like, but it's on its side, yes? As you can see, that our domain is not all real numbers, is it? Now this is where I would want, for these types of problems, set notation and interval notation. And so set notation would be something like this, where we would say, hey, we're talking about x's such that x is greater than or equal to what? What's the smallest x value that you see? -2. And it has to get larger from there, because the graph is going in that direction, yes? It's kind of hard to see that arrow on there. I see. No, we have to use little squiggly brackets. Then, that one is set notation. What would it look like to say that x is greater than or equal to -2 using interval notation? Where are you starting? What's your leftmost part or point? -2. Where is it going? On towards infinity. Can you be at -2? Yes. Can you be at infinity though? There you go. Okay? I want both of those. I want you guys to get used to the idea of writing both. We have to do the same thing for the range now. The question is, there's arrows kind of pointing upwards and downwards on this problem, correct? So, what values, is there any limitations to my y values, I guess you should say? I don't think there's any limitations. That means it goes on for ever in both directions. So y such that what? Y is all real? All real numbers? I'm okay with that. Y such that y is all real numbers. You can, technically we could do this. Whoops, that sounded good. It's a capital R, and sometimes they put an extra little line through it. So you could say that y is contained in all real numbers. And if I wanted to use interval notation, I can't use brackets because it's going from -infinity to positive infinity. And remember, you can never be at infinity, so therefore it's parentheses on both ends. And the last question of this is, is this a function? All you have to do is go like that once and say, no. Not a function. Done. For problem 20, it's a line. Lines go forever in the x direction and in the y. So basically copy the range from 19 and do the same thing for the y's, or the x's, sorry, for your domain. Because the domain and the range are all real. So you guys can fill that in. Is it a function? Yes. And is it one-to-one? Yeah, one-to-one.
You don't have to draw the arrows, do you?
No, you're okay with draw. You don't have to draw arrows. We're using it as a test. Now, 21. Are the x's going where?
To the side.
To the sides, which means they're going to infinities. So therefore, can you guys agree that your domain is from negative infinity to positive infinity? Or all reals, okay? Because the arrows are going this way. Now, look at those arrows. At the ends, they're going straight across. Are they going up or down? No. So actually, the range is stuck between what values?
2 and 2.
Not 2 and 2.
Infinity and infinity.
No. What's the highest y value?
2, 1.
1. What's the lowest y value?
Negative.
Right. So we're going from 1 to, between negative 1 to 1, right? Now, are these included or not included? Can I be at 1?
No.
Yes. Can I be at 1 and negative 1? Yes. So therefore, they got closed brackets. You guys can do the set notation for this. Actually, set notation for this one, you'd say y such that, how do I write that inequality? Well, we could use 2 of them, or I could use one compound inequality and do something like this. And put y in the middle, right?
Yeah.
So y is between negative 1 and 1. So negative 1 is less than or equal to y, which is greater than or equal to 1, or less than or equal to 1. So therefore, it's just 1 inequality versus 2.
Wait, when you said for number 20,
Does it pass the vertical line test?
yeah.
Yes. So it is a function. Is it 1 to 1? It's not, because right there and at negative 1, so it's not 1 to 1. Okay, problem 22. We'll talk about the domain and range. You guys fill it in. What's the domain? From?
2 to 2 to 2 to 2.
2 to 2 to 2 to 2. Almost, it's from negative 2 to 2. What's the range?
2 to 2.
Negative 2 to 2 again. Okay? So both the domain and the range, are those endpoints included? Yes. Question is
No.
it a function?
No.
No. So it's not a function. Okay? I'm not filling these things in. We're talking about them. 23. It looks like my x values go for ever. It's going to continuously go in both directions forever, right? So x's are all real or infinity to negative infinity or negative infinity to infinity. Range starts where and goes where?
Negative 1.
Negative 1 and goes to
2.
positive infinity. Guys, pay attention. This is negative 1 and it goes up. So therefore it goes from negative 1 to positive infinity or just infinity. Is this a function?
Yes.
Yes, it's a function because it passes the vertical line test. It's not 1 to 1 because I just found one instance where it doesn't work on a horizontal line test.
The graphs already figure out. Can you write how you write the domain? Non-function.
24. The domain only goes from 0 to
0 to 2.
2. The range goes from the bottommost number, negative 2, all the way up to
Wait, what's the domain?
2. And it is
Not a function.
not a function.
Wait, what's the domain?
Okay, homework is on page 158, 8 through 9, and 18 through 19. And please finish up all those examples that we did by filling in the range and the domain and if it's a function or not.